2, and I'm focusing on the paper. So let's check tonight's paper. Remember to subscribe. Remember to share so that you may invite a friend. Thank you for joining. Already people are in the program and this is great. So we can get started, ladies and gentlemen. We can get started. Remember to subscribe. Remember to share so that you may invite a friend. We're going to cover something on the 4-figure mathematics table. Use logarithms correct to 4 significant figures to evaluate the third root of 24.36 multiplied by 0.066547 divided by 1.48 squared. So that is the first question. Solution. So we are supposed to organize this work in a very decent manner. Very decent. Such that we start with number, then the standard form of the number, standard form, then the logarithm of the number. That's how you're supposed to organize this. Remember again, just remember something here, that we've been told to use logarithms, not logarithm tables. So that means you are free to use the logarithms from your calculator. So the first number is 24.36. And in standard form, this shall be 2.436 times 10 power 1. Then it becomes, for you to do now the logarithm, we have the whole number of the logarithm, which is 1 point. We are picking 1 from the power of 10. Then now we go to the calculator and you type log. I hope you can see log from your calculator. 2.436. This is giving us 3867 to 4 decimal places. Then after that, you proceed to the second number. The second number is 0.066547. So the standard form of this becomes 0.6655 instead of 5. Okay, instead of 547, if you are reading from the math table, you can make it 4 significant figures. If you are reading it from the math table, sorry, there is a 6 that I'm introducing here. If you are using the math table, you can make it 655 times 10 to the power of -2. But now in our case, whereby this logarithm can even be computed from the calc, which is not a 4-figure table, we can just have our 547 because I'm reading from the calc. If it was the math table, I would have rounded it to 4 significant figures because 4-figure table handles 4 significant figures. Then the log now becomes with bar 2 according to the power of 10. So you write now the log of 6.6547. This gives us 8231. Now look at this. The two numbers on the numerator have been multiplied. Therefore, their logarithms should be added. Because they have been multiplied, their logarithms should be added. Their logarithms should be added. Let's add manually. Kindly don't apply the calculator in the addition now. Please don't try the calc when adding up such a thing. Remember to subscribe, remember to share so that you may invite a friend somewhere. Let's know where you're watching us from. Please remember to subscribe and to share so that you may invite a friend to our live broadcast. 8, 9, 0 because of 10, we carry 1. So 3 plus the 1, we get 4. Then plus 8, we get 12. Carry 1. This now becomes 1 plus 1, then bar 2, making it a 0. Making it a 0. You pack that answer from the numerator. Then you go to the denominator. At the denominator, we are having 1.48. So it's 1.48 times 10 power 0. So the log here is 0. We read the log from the calc again. 1.48. This is 1703. 1703. 1703 that way. But now this number has been squared. Now that it has been raised to power 2, then the logarithm should be multiplied by 2. If it had been cubed, we would have multiplied by 3. If it had been raised to power 4, we would have multiplied by 4. So we multiply by a value equal to the power. So now we're supposed to multiply this by 2. Yeah, we multiply by 2. We get 6, 0, 4 carry 1, 3, then 0 at this point. So we've squared now, which is equivalent to multiplying the log by 2. Now, after dealing with the denominator, and we did something to the numerator, now we are supposed to compare the two. Remember, the numerator and the denominator have been divided. So the overall logarithm from the numerator and the overall log from the denominator should be subtracted, because the numbers are divided, the logs are subtracted. So this log, the final log from the numerator, and the final log from the that is the denominator, should be subtracted. Allow me use the space beyond this provided space that way. So 8 minus 6, that gives us 2. 9 minus 0, that remains a 9. Then now something else that we have is a 0 here, minus 4. So we make it a 10 minus 4 to give us 6. Then this became 1. So we borrow 1 from 0. We borrow 1 from 0, making it 11. 11 minus 3 is 8. Point. We borrowed 1 from 0. Remember, we are subtracting. We borrowed 1 from 0, so it's about 1. It is about 1 now on the characteristic part. Now, with bar 1, ladies and gentlemen, with bar 1, we are supposed now to consider the overall root, which is root 3 that we are obtaining. If we are obtaining root 3, ladies and gentlemen, we divide the final logarithm by 3. So we divide everything here by 3. In the process of dividing by 3, we ask ourselves, is the characteristic, that is the whole number part of this log, is it divisible by 3 without a remainder? Or is it a multiple of 3? And it's a no. Bar 1 is not a multiple of 3. So how can we make it 3 or a multiple of 3? We make it 3 by borrowing 1, by borrowing 2. It's a bar 1. So when we borrow 2 from bar 1, it becomes bar 3. So bar 3, we divide it by 3. Then on the other side, whereby on the Mandisa part, we are having 0.8692. Now, the 2 that we've borrowed from the characteristic is now handed to the Mandisa part. So it becomes 2.8692 out of 3. So bar 3 divided by 3 is bar 1. And now I can use a calculator at least at that point. 2.8692 divided by 3 also. We are getting 0.9564. So 9564. Now it is this logarithm which we supposed to find the anti-log for. So we find now the anti-log. We find the anti-log of bar 1.949564. So now it's at times 10 power negative 1. If the log is bar 1, then the number in standard form should have been having or should have had 10 power negative 0. Remember, we are doing now the reverse. So we now get the shift log, the log inverse of 0.9564. This is giving us 9.045. 9.045 that way. 9.045. And if this is the standard form, then the number is supposed to be 9045. 0.9045. So that is now the number. Thank you to those who are following. I can really watch your motivating comments. Let's know whether you're getting something as we go to errors and approximations. Remember, you can always find these lessons even after the presentations. You can still find them. You can still find them. About our revision programs, remember to consult through 07 04 15 33 66. Errors and approximations. Find the percentage error in the total length of 4 rods measuring 12.5, 24.5, 12.9, and 10.1 centimeters, or to the nearest 0.1 centimeter. In other words, the accuracy that has been used in the recording of all these 4 lengths is 0.1. So if we have an accuracy of 0.1, ladies and gentlemen, thank you, Machako School. Thank you, Sheila from Sironga Girls. Thank you, Meru School. Thank you, Kiambuthia Secondary. Thank you, Njiri Secondary. Samuel from Kiampa, Chesamisi Boys. Thank you, Jiri School. Thank you, thank you, thank you. Thank you, Mandera School. Thank you, Ajir Girls. Kapsabet Boys. Thank you so much. Thank you, thank you, thank you. Makweni Girls. Thank you so much. Moi Secondary School. Thank you so much, Mohammed. Thank you, thank you. Ashili from Nyabisase. Thank you so much. Kiambu Township. Thank you. Thank you, thank you. Mubiru from Mpata. Thank you. Kaimosi Boys. Thank you. Let's now proceed, please. Let's proceed. Let's proceed kindly. Let's proceed. Tag your school, tag your math teacher. Be proud of your school kindly. It is your school that is making you who you are today. Remember to share to a friend, either from that particular school or from a different school, as long as it is a friend that you value and you'd like to succeed with. Kindly invite them to our programs. Find the percentage error in the total length of 4 rods measuring. We are given the accuracy as 0.1. If this is the accuracy, we can find absolute error. There are 2 types of absolute errors here. Absolute error, which is incurred in the recording of the dimensions, and absolute error incurred when operations are done on the measurements. So absolute error on the recordings is given by accuracy divided by 2. Accuracy divided by 2. Therefore, the first length, which is 12.5, we can now find the range within which it lies. So 12.5 plus or minus 0.1. And this range is going to be from 12.45, or when we add 12.55 centimeters. The second length, which is 24.5, it is to the same accuracy. So they are sharing absolute error, which is 0.05, sorry, which is 0.05. So they are all sharing the absolute error. So the upper limit of this second measurement shall be 24.45, and the upper limit 24.55. Then we are having 12.9. 12.9. Therefore, this is 12.9 plus or minus 0.05, the absolute error. They are sharing absolute error. They are sharing absolute error. So this shall be 12.85. And on the upper side, when we add 12.95. 12.95 that way. Then finally, we are having the last dimension here, which is 10.1. So 10.1 shall lie when we add the same absolute error of 0.05, and that should take us to, when we subtract, it shall be 10.05, and when we add, we shall be at 10.15. 10.15. So these are the limits within which the dimensions have been recorded. They are all to the same accuracy, so they are sharing the absolute error in their recording. Now we can get maximum sum. Find the error in the total length, so in the addition. So we are going to find maximum sum. Maximum sum shall be found when we add the upper limits of the four rods. 12.45 plus 24.45. We continue adding 12.85 and finally 10.1. I'm on the upper limits, sorry. Upper limits. Sorry for that slight mistake. Sum maximum. We use the upper limits of each dimension for us to get maximum sum. So the maximum shall be 12.55 plus 24.55 plus 12.95 plus 10.15. What is this giving us? Let's carry out the sum. 12.55 plus 24.55 plus 12.95 plus 10.15. This is exactly 60.2. 60.2 centimeters. Now we can get minimum sum. Minimum sum shall be when we add the lower limits. The first lower limit is at 12.45. The second one is 24.45. Then we have the third one is 12.85. Then the last one is 10.05. So let's add this. 12.45. 12.45. I'm adding 24.45. Then adding 12.85. Then adding 10.05. This takes us to 59.8. 59.8. And finally, actual sum. Actual sum. We have found maximum sum, minimum sum. Now actual sum. Actual sum will be the sum of the lengths of the rods just as they were captured. 12.5 plus 24.5 plus 12.9 plus 10.1. This shall be equal to 12.5 plus 24.5 plus 12.9 plus 10.1. This is 60. Exactly 60 centimeters. Now with maximum, minimum, and actual sum, we can find absolute error in the recording. No, absolute error in the computations. So we go back again to the word absolute error, but now after operations. So this shall be given by maximum minus minimum over 2. Maximum minus minimum. We divide now what we will get there by 2. So 60.2 minus 59.8. Then we divide this by 2. I'm getting 0.2. 0.2. Then now with this, for us to proceed to percentage error, we need relative error times 100%. Relative error is given by absolute error over actual. Then now we make it a percentage. Then we now make it a percentage. So we take 0.2 times 100 over 60. Yeah, times 100 over 60. And this is giving us a third percent. Yeah, a third percent, or 0.333 recurring. That way. Number 3. In the figure below, QT is a tangent. QT, we can see the length QT, right? QT is a tangent. PXRT and QXS are straight lines. PX equals to 6 centimeters, as you can see on the diagram. Then RT, as you can see, equals to 8. RT is here, 8. We have PX, 6. Then 4.8, that is QX. Then we have 5 for QS. XS, that is. Find the length QT. For us to find the length QT, there is first of all a known length, which is internal, inside the circle. So we first deal with intersection of chords inside a circle. When chords are meeting inside a circle, we say this. If the chords are just as written, we have P to X, then from X to R. When you multiply those two lengths, you are supposed to get Q, X, and XS that way. So P to X is equal to 6 multiplied by a known, which we can call X, equals to 4.8 QX, then XS 5. So for us to get X, which is our XR, shall be 4.8 times 5 over 6. And this gives us 4 centimeters. So if this is 4 centimeters now, then it means now we can relate a chord that is PT intersecting externally with a tangent QT. Now, when a chord is intersecting externally with a tangent, we usually say this: the whole portion of the chord, that is PT, multiplied by the outer portion of the same chord, RT, should give us the tangent squared. Therefore, we shall talk about PT, whereby we have 6, we have 4, and we have 8, giving us a total of 18. 18 multiplied by 8, the outer portion, should give us a known QT squared. So how do we get QT? By taking the square root of the product of 18 and 8, which is a 144. Therefore, we shall talk of QT being equivalent to 12 centimeters in length. 12 centimeters in length. Have you subscribed? Have you subscribed? Are you sharing your link with friends? The link is already here. So please invite a friend to this particular live broadcast. We are about to cover a very good question on area approximation by trapezium rule. So kindly be found, be present. Please be found here. Kitale School, thank you. St. George's Girls, wow. That is great. That is great. Those are our neighbors. I teach at St. George's Comprehensive School. So thank you so much, my neighbor. Kaimosi girls. Wow. Thank you, thank you, thank you, thank you. Watching from Garissa, from Moranga. I really love this. I really love this. Olmoran High. Thank you so much, Grace. Let's now proceed. Let's proceed. Thank you, thank you. St. Paul's Boys. Wow. Chebukwa High. Kaimosi Girls. Mangu High. Thank you for recognizing your school. Thank you for recognizing your school. Lavington School, thank you. St. Paul's Boys Moranga, thank you. Merisho School, thank you. Nyeri High, thank you. Riruta, thank you. I really like the connection here. Let's get to the trapezium rule now, ladies and gentlemen. Nairobi School, thank you. Let's get to the trapezium rule. Use the trapezium rule with 7 ordinates. Look at this. With 7 ordinates to find the area bounded by the curve y equals to x squared plus 1, lines x equals to -2, x equals to 4, and x-axis. All right, let's begin here. In case we write the values of x between -2 and 0, how many ordinates are we going to achieve? How many ordinates from -2, -1, 0, 1, 2, 3, 4. These are now the ordinates. These are the ordinates. They are automatically 7. Automatically 7. From -2 all the way to 4, they are automatically 7 ordinates. The question is demanding we use 7 ordinates. Just a precaution. Sometimes you'll be given ordinates which are not going to fit when you use the intervals of 1 unit, the way I have used. So in a case whereby, for example, you are told to use 14 ordinates, that means when you use 1 unit interval for the values of x, you shall not achieve 14 ordinates. And in such a case, you introduce the half interval. From -2, you go to -1.5 before -1, then -0.5 before 0, then 0.5 before 1. So you introduce the 0.5 interval. But for this case, when you use a complete unit interval, we are actualizing our 7 ordinates according to the demand by the examiner. Now, we are supposed to get the values of y. Let's get the values of y by fixing the values of x in this equation to know the corresponding values of y. For us to know the corresponding values of y, let us substitute. We substitute. Y equals to x squared plus 1. So -2 squared plus 1. That becomes 5. -1 squared plus 1. That is 1 plus 1, which is at 2. Then 0 will give us 1. Then at 1, we shall have 1 squared, which is 1, plus 1, which is 2. 2 squared plus 1, giving us 5. 3 squared, 9, plus 1, giving us 10. 4 squared, 16, plus 1, giving us 17. So we have filled our table. The function is very simple. This one, you don't even have to use a calculator to fill it. Now, the other thing that you're supposed to know, according to the trapezium rule of area approximation, area is usually estimated using the formula area equals to half height, which is the interval, into the first value of y plus the last value of y, then 2 multiplied by the other values in between, the first and the last, until the value of y just before the last one. just before the last one. So substituting into this formula, we begin with half and we multiply half by 1 because the interval here is 1. From -2 to -1 to 0 to 1 to 2, 3, 4. We are using intervals of 1. So that is where our height comes in. Then now we go to, we go to the values. We go to the values now of y. And we begin with the last value, the first and the last, 5 and 17. 5 plus 17. Then we add 2 multiplied by the values of x now in between the first and the last. The values of y, in between the last and the first. 2, 1, 2, 5, 10. That is a very clear substitution. A very clear substitution. Now, with that clear substitution, it means we can finish up, guys, by now going to make a good use of the calculator. Remember, this is a 0.5. Half times 1 is just half. Then into, we are having a 22, 5 and 17. 22 plus 2, 3, 5, 10, 20. So that's a 40. It's my hope that I have computed well. 2 plus 1, 3, 5, 10, 20. So 20 by 2 becomes 40. So we'll be now taking 0.5 multiplied by 62, which is going to be exactly 31. Exactly 31 square units. 31 square units. So that is the application of what we are calling the trapezium rule. Remember to follow up with our programs for proper equipment towards your KCSE. Just remember. Wow, I'm seeing Moka girls. Thank you so much, Moka girls. Thank you, Nairobi School, Mtaa Secondary, Peter Kariuki, Riruta Central. Thank you for being around. St. Paul's High School. Thank you. We proceed now. We proceed. Ambira Boys, thank you. Bavuni, thank you. Thompson, thank you so much. Kebirigo, thank you. Ituru High School, thank you. Thank you. Koelel Forces, thank you. Okay, we proceed to number 5. Number 5. Tumutumu girls, wow, thank you. Let's follow up keenly now. Let's now check on our focus. Given that x equals to the square root of TP divided by 2 mu plus P, make P the subject of the formula. Because there is a square root sign, we can square both sides of this particular formula. So squaring both sides, this becomes x squared equals to TP. Now the square root sign is cancelled by the squaring. The reason it is being cancelled is because we are squaring this part and this other part, which is having TP out of 2 mu plus P. This part, square root means raised to power half. So when raised to power half, we are also squaring by multiplying it by 2. To square is to raise to power 2. So the existing power is a half, and we are now multiplying by 2. So we square both sides such that power half cancels out. Then x becomes power 2. So we'll have 2 mu plus P that way. With this now, remember we are making P the subject. We can cross multiply. X is automatically over 1. Therefore, this shall be now 2 mu x squared plus, I'm multiplying this way, cross multiplication. Then x again multiplies P equals to TP. You see? So at such a point, Kitale School, Joina Fula, thank you. At such a point, Tetu High, St. Anthony Boys, and Kaimosi, at such a point, you group all the terms that have p together. You group them together. So 2 mu x squared equals to tp minus px squared. So the term which has p is taken to the other term which is also having p. So we can factor out p now to have t minus x squared. Then on this side, we are having 2 mu x squared that way. At this point now, ladies and gentlemen, yeah, St. Paul's boys, Muranga, thank you so much. I've seen you. At this point, we can now remain with the p. We can now remain with p by saying 2 mu x squared divide by, we divide both sides for us to remain with p now. We divide both sides by whatever multiplies p to remain with p. Whatever multiplies p in this case is t minus x squared. So now, as long as you've managed to arrange all the terms until you remain with p on one side, you are good to go. You have already made p the subject of the formula. Solve for x in the equation below. Number 6, logarithm of 3 in brackets x plus 9 then equals to 3, the logarithm of 3 plus 2. In such a question whereby, Asumbi girls, thank you so much. In such a question whereby we can clearly see that there is a constant like 2, we usually introduce logarithms in such questions. Remember again, there is no common base in this particular question. So we can introduce base 10 in the particular question. When the base is not provided, learn to introduce base 10. Look at this. The expression to become the log to base 10 of 3 x plus 3 equals to 3, the logarithm to base 10 of 3 plus 2. Just that. That arrangement alone is very good. Just introduce base 10. After that, remember that a law of logs that says the log of a number to the same base equals to 1. So if the log of a number to the same base equals to 1, then we can now introduce log of 10 to base 10 where there is 2 or where there is a constant. So log to base 10 of 3x plus 9, I've just opened that bracket, equals to the log, 3 log to base 10 of 3 plus 2, the log of 10 to base 10. So in this case, the log of 10 to base 10 has a value equivalent to 1. Therefore, we have not tampered with the value of 2 because log of 10 to base 10 is 1. All right. We remember again a law of log that says n, the log of any number becomes log of this number power n. So the multiplier, the scalar multiple now changes to a power of that particular number. Therefore, now we will be talking about the log to base 10, 3x plus 9 equals to log to base 10 of 3 power 3. So 3 becomes a power to the 3 now, according to this law that we've stated. This is a 27 plus the log of base 10. 10 squared. 10 becomes squared because of the 2 here. So this becomes 100. I've applied that law. Very good. Nembo girls, thank you so much. Tau Id girls, Samoa boys, thank you, thank you, thank you. Number 6, somebody has already done. Thank you so much. I can see somebody posting the answer. We can confirm. We can confirm. Now, we can apply the first law of logarithms, which says what? Which says whenever you have the log of b to base a plus the log of c to the same base, this one you can sort out by taking the log to this common base and b is multiplied by c. If that is so, then we can apply it to our right hand side of this equation. The log 2 base 10, 3x plus 9 equals to the log 2 base 10, 27 multiplies 100. And at this stage now, we can't continue applying more laws of logarithms. We can only now drop logarithms, not cancel logarithms, drop logarithms and equate the right hand side to the left hand side. Therefore, 3x equals to, we take 2700 and we subtract 9. This gives us 2691. 2691. Let me write it clearly. 2691. Then to remain with the value of x now, we are supposed to divide through by 3. 897. That particular student was very correct. 897. 897. That is now the final value of x. Kwale boys, thank you so much. And Nyanya secondary, thank you. Look at number 7. The points 5, 5, -3, -1 are the ends of a diameter of a circle center A. Determine first the coordinates of A. Let me give a sketch for this particular information. Then we shall be proceeding. I will use the space here, which is a big broad. We are having a circle here, whereby if we assume a diameter, there are some coordinates showing the ends of the diameter. -3, -1, that is end P of the diameter. And the other side, end Q, we are having 5, 5. This is Q. Now, these are the ends of the diameter, the ends of the diameter. If these are the ends of the diameter, then we are told that the center of the circle is A. The diameter must pass through point A. So this question is in paper 2, form the work, graphical methods, the last topic. But something that we're supposed to understand is that we are going to apply knowledge from paper 1, vector 1, whereby we are supposed to learn the concept of midpoint. So A is the mid of the two ends of the diameter. And if so, then it means the coordinates of A, which is our mid in this case, shall be x1, x2 over 2, then y1, y2 over 2. So in this case, the coordinates of A shall be, we take -3, we add 5, and we divide by 2, comma, we take -1, we add 5, and we divide by 2. y1, y2 over 2. Therefore, the coordinates of A are going to be, the coordinates of A shall be 1, then 2, because this is 2 over 2, which is 1, and 4 over 2, which is 2. So that is the coordinate. That is the coordinate of point A. Well calculated. Thank you, Mita Josephat from Taranganya Boys and Imbi School. I'm really impressed by the presence of all of you. Thank you so much and continue growing in academics. Remember to subscribe, ladies and gentlemen. Please remember to share with friends